Hi everyone, in this video I would like to share to you how to configure a metro network to integrate with IP backbone network to provide MPLS VPN service. In this topology, on the left side is the metro network, including CSG or cell-side gateway router at the access layer, and in the middle is AGG routers or aggregation, and the MTC router or the metro core. On the right side is the IP backbone, including ASPR, which is the border router connect to the metro network, P and PE router, and route reflector router or R router. The metro network and core network are segmented to different AS systems, and within the metro, the access layer and aggregation layer are segmented into different OSPF area. The CSG router in metro core acts as a PE router connect to customer or to other equipment for different kinds of service. So on GSG, VIFs will be configured for different kinds of traffic. The CE here can be a router at the customer side, or can be the not B or E not B in mobile system. The same, the CE in the metro network can be a gateway to internet, or the gateway of a mobile system like EBG, MSC, or media gateway. Our purpose is to create an end-to-end VPN connection from CSG to PE router in the core network, to have CE A2 communicate with CE A1. So let's move on the control plan for the inter-AS VPN. Because the core network and metro network are in different AS systems, so in order to advertise VPN prefix from one AS to another, a method called inter-AS VPN should be employed. There are different options. In metro network, we choose option C, with use route reflector in each AS to exchange VPN v4 prefixes. So the route reflector in core network will establish EPGP multi-hop VPN neighbor relationship with a route reflector in metro core network. The route reflector here is the metro core router. This router will act as an inline RR router. It means that it participates in both forwarding and controlling function. This metro core also acts as an ASPR in the metro domain to connect to the ASPR in the core network. So let's see how to advertise the VPN prefix from one AS to another. For the VPN prefix from PE router in core network, then advertise to RR router. The VPN prefix then will be advertised from RR router to its EPGP neighbor, that is the metro core. So by default, because this is the EPGP neighbor, so by default RR router will change the next hop to itself. But our purpose is to create an end-to-end VPN. So we need to keep the next hop at the PE router. So on our router here, we need to configure the next hop unchanged. It means that the IP VPN prefix advertise to metro core, the next hop will be the address of PE router, not the address of RR router here. The same for the metro core router. When core router receive a VPN request from the RR router, it will advertise to its RR router clients, which are AGG in the aggregation layer. AGG also acts as an inline RR router, so it will advertise the VPN request to CSG router, here. So when the CSG router receives a VPN request from the core network, the next hop is the PE, the address of PE router. On the reverse direction, also the same. The VPN request from CSG advertise to AGG, then AGG advertise to MTC or metro core. The metro core by default will modify the next hop to its self IP address. So we need to enable the next hop unchained on metro core so that it keeps the next hop to be the IP address of the AGG when advertising the IPv4 request to router in the core network. When the AGG advertise the VPN request to metro core, the next hop to set will be set to itself, not the IP address of CSG, because the number of CSs is very large. If we set the next hop on the CSG, we need to advertise the loopback IP address of CSG to the core domain. So the number of prefixes need to be advertised or need to be processed on the core network will be a lot. So instead, we will set the next hop for VPN prefix from CSG to AGG. Then we only advertise a small number of address on the AGG to the core domain. So when PE router in the core domain receive a VPN request from the metro, the next hop is the IP address of the AGG. But in order for the PE and AGG install the VPN request to their routing table, the next hop must be reachable. It means that from AGG can reach to the PE address. In order to do that, we need to advertise IPv4 loopback address of PE in the core network to route to the RR and then to the metro network, and also the IP address of AGG need to be advertised to BGP and advertised to the core network. The issue here is that we would like to establish an end-to-end LSP directly between the AGG to PE. But there is no MPLS on the link between metro core and ASPR. So how to advertise the label from the core domain to metro domain? Then we have to use BGP IPv4 plus label or RFC 3107, or in the Cisco iOS SR, we call this a BGP IPv4 label unicast. When we enable BGP IPv4 label unicast, BGP will advertise IPv4 prefix together with the label that the router assigned for that IPv4 prefix. Within each domain, we would also use BGP IPv4 label, because if we don't use IPv4 label, we have to redistribute the loopback address PE router in the core network in the metro core. We have to redistribute on metro core from BGP to OSPF, and on the ASPR it is the same. We have to redistribute the IP prefix IP address of the AGG to OSPF so that the PE router here and the AGG can communicate each other. But when we use BGP IPv4 to reach ASPR and the Metrocore router, when we use BGP IPv4 label unicast, we establish an end-to-end LSP that running across the boundary between two AS systems. So there are some key points here that in order to establish an end-to-end VPN from AGG to PE router, we need to enable Next-Hop Unchained on Metrocore router and router on the RR router in core network. And in order to establish an end-to-end LSP from AGG to PE router, we will use BGP IPv4 label unicast on the link between ASPR and Metrocore and within each domain. The third noted is that the next hop for VPN prefix from CSG to the core network will be the address, the back address on AGG, not the address of the CSG. So in our topology, let's see how the prefix to be advertised. There are two kinds of prefix, IPv4 and VPN-v4. With the VPN-v4 PE router, we advertise to our router. Our router we advertise to Metrocore with the next hop unchained. It means that the next hop is still the PE router. Metrocore then advertise the VPN v4 prefix to its RR clients, which are AGG router. AGG then advertise to CSG. For the IPv4, PE router advertise its loopback address to the RR router. RR router then advertise to ASPR. ASPR then advertise this IPv4 prefix to the Metrocore with a label that is assigned to this IPv4 address. Metrocore also then also advertise this prefix to AGG router with label. These label are BGP label, unicast label. So from CSG, when it want to communicate with the PE router here, the next hop will be the PE router in core network. So let's see how the data is forward between CE-A2 to CE-A1. The packet, when the CSG receive an IP packet from CE-A2, we check its VPN v4 label table, and in this table it said that if the CSG want to go to the destination address 10.0.1.1, that is the loopback address of P1 in the core network. It has to send the packet to the next hop at the address of 10.2.1.1. That is the IP address, the loopback address of AGG2. And it also adds a VPN label 24006 into the packet. Then the packet will be forwarded to the AGG2 using the algorithm interface 800 and with that LDB label. So the packet from CSG to AGG only has one label, that is the VPN label. At the AGG, when it receives a packet with the VPN label from CSG, it also checks in its VPN v4 table. In this table, it says that If it wants to forward the packet to the destination address of 20.0.1.1 of the PE1 router, it will send to the next hop at the address 10.0.1.1. This is the IP address of PE itself, and it will swap the VPN label using a new VPN label of 24005. The next step, AGG will look up its IPv4 label unicast table, and it says that if you want to go to the next hop at the address 10.0.1.1, it will send the packet to the next hop at IP address 10.2.0.1. This is the IP address of the Metro Core network, and using the label, another label here is 24004. This is the unicast label and advertised by the Metro Core. And another step is it will check in its MPLS forwarding table. It want to go to the address of the Metro Core. It will forward the packet out to the interface GI000 and using the LTP label of 16. This is LTP label. So the packet going out of the AGG will have 3 labels in its label stack, including VPN label, BGP unicast label, and LTP label. We'll see it here in the picture. The packet going out of the CHG has only one VPN label, and this packet arrived at AGG. The VPN label will be replaced by another VPN label assigned by AGG2 here. This VPN label is to PE router in the core network. And then from AGG2, if it wants to go to PE address at the core network, it will send the packet to the Metro Core using a PGP label 24004. And the next step is it wants to go to the Metro Core. It has to send the packet out of interface GI00 to the AGG number 03 here, and using LTP label of 16. So the packet going out of AGG number 2 has 3 labels. At AGG number 3, when it receives a packet LTP label, it will check and look at the MPLS LTP table, and it will remove the LTP label, the stack, and forward the packet to the MTC with 2 labels left. Because AGG is the last hop to reach the Metro Core in the Metro domain. So before sending the packet to the Metro Core, it will remove the LTP label. At Metro Core, after receive the packet with 2 label, it will check in its BGP IPv4 label, and then it will swap the BGP label into a new label of 24003. This label is advertised by ASBR to Metro Core. When the Metro Core forwards the packet to ASBR, when ASBR receives the packet with BGP label, it will check in its MPLS forwarding table and then swap BGP label by the LTP label, because inside the core network, ASBR can reach the PE router by the IGP protocol here is the OSPF. So from ASPR to the PE, we use the LTP label instead of BGP label. And ASPR then forward the packet to P router. P router will remove the LDP label and leaves only VPN label, because P router is the last hop to reach the P router, so it will remove the label before forwarding the packet to P router. P router when receive the packet with only VPN label left, it will check, it will remove the VPN label and forward the packet to CA1. So that is the flow to forward the packet from CA2 to CA1. So that is enough for theory principle. So let's move to configuration.